All right, hello once again, Jeff Scott of Rankin Technical College. We've been going over the online PDF AppInventor2 Create Your Own Android Apps by Wolber, Abelson, Spertus, and Looney. We're up to chapter 19 of 24. And this chapter is on programming lists of data. And as mentioned here, an app's data is rarely restricted to a single memory slot. More often it consists of lists of information which might be very complex. So in this chapter, they examine how App Inventor handles data, the fundamentals of programming both static information in which data does not change and dynamic information in which data is entered by the end user. Now you already should know this, that you specify list data in App Inventor with a variable, but rather than giving it a single memory location, you give it a list. So here is, for example, a list of phone numbers with 3 in there. You create a list variable in the blocks editor by using the initialize global variable block and then plugging in the make a list as we just saw up above. And you're not limited to 3. You can put as many items in here as you need to. By default, it has, I believe, only 2 sockets, but you can put in as many as you need by clicking the blue square right there, and it'll bring up item, and then you can drag in as many of these as you need. As far as selecting an item in a list, as the app runs, as mentioned here, you'll need to select list items. You access them by using an index. That is, by specifying a position in the list. Unlike the way it's done in most programming languages, you use the indices 1, 2, 3 as opposed to 0, 1, 2. You can use indexes to traverse a list. All right. In many apps, you'll define a list of data and then allow the user to step through, which is also known as traversing it. As mentioned here after the example, when you, I guess it's, there you go. When you traverse a list, the list item you're selecting changes every time. All right. Now, it's very popular when you go and traverse a list. All right. If you want to traverse it to do something, it's very popular that you will use some kind of a loop. It just makes sense to do that. So they've got a thing here with a list of paint colors. So here we've made the list. We've got red, and we've got green, and we've got blue. All right. When you click a button, what are we doing? Well, we're setting the paint color to something. Now, there's nothing at all wrong with the example that they give here. But again, it's not exactly what I call reminiscent of real life. Again, quite often you're going to go and be looking through a list for a certain value. Maybe you're looking for a name. Maybe you're looking for a salary. Maybe you're looking for, I don't know, people who work in a certain department. It doesn't really matter what it is. That's why, like I said, typically you'll end up putting this into some kind of a loop. All right? Here's an example of your program blowing up that they show here. This is the middle of the page, or I guess the top of the page on 299 here. And with what they've shown, all right, you've got a list that has only 3 elements in it, and you're trying to reference a 4th element. So you're going out of bounds is the way it typically is referred to. So this isn't a message that you'd want your users to see, as it says. And what it is you've got 3 colors, and you're traversing your way through here. But once you get to number 1, then number 2, then number 3, since you're adding 1 to it, it'll make it 4, but you only have 3 colors. So instead, you wrap around. You put an if in there that says if you've reached the end, set it back to 1. That's a very popular way of handling this kind of problem. Now, you don't want to do this. You don't want to say, well, it's greater than or equal to, and I guess they don't even have the example in here, 3. All right, you want to use the length of the list. What they're doing here in the example is very, very good. And what I mean is, all right, what I mean is they are keeping code dependencies from happening. When you get a code dependency, what you're doing is you're saying, hey, as long as it's greater than or equal to 3 or 17 or whatever it is, you don't want to do that. You want to use the length of your list. So that way, as the program goes on and you possibly add things to the list or remove things from the list, you're always going to be working with the right number of elements that are in the list. Creating input forms and dynamic data, guess what? We looked at this. Most often, you're going to want to give your user the ability to deal with dynamic data. All right? Maybe in this color list, maybe you give them 3 colors initially, but you want to let them add their own colors. Okay? We didn't have purple in there. Maybe you want to let them add purple, for example. When you want a list to begin at being as empty at the start, you do this. You create the empty list. The example we saw before, we put 3 phone numbers in there. All right, that may or may not be something that you want to do. A to-do list is a really good example. You might start a to-do list with an empty list. But as you go on, you want to be able to add things to the to-do list. After you do them, you want to maybe be able to remove them. So that's dynamicity. All right, you want to be able to change things as the program is running. So you define an empty list, and then you want to be able to add items to it. All right, so you add items to the list with the add items to the list. You want to be able to display a list. So you add items to it, then you want to display it. Okay. And you also want to be able to remove an item from a list. So we had an add list item and we've got a remove list item. Notice with the remove list item, you put an index in there so it says which one you want to remove. Now we did look at a list picker, which they're talking about here. You may or may not remember it, but we did look at a list picker when we had the Amazon app. And remember, there was a before picking and there was, I believe, an after picking. But the idea with a list picker is it looks like a button, but when you click it, it shows you a list of possible values. There you go. So you can do things before it's been picked or after it's been picked. Lists of lists, all right, as we're perusing our way through here. If you remember, again, with the Amazon app that we did for Chapter 13, there was a list of lists. The app was designed to return 5 books based on the subject you put in there, all right? But it really was a list of 5 books, and each one of the books themselves was another list that had the book's title, the book's price, and the book's ISBN number, all right? So again, the items of a list can be of any type, including another or a list themselves. So we have seen this. And that pretty much is it for the chapter. All right? So if we look in here, lists can be used in basically any app. As your apps get more complex, the chances of you using a list, they're virtually 100%. Understanding how lists work is fundamental to programming, so that's what this chapter was about. In the next chapter, chapter 20, we'll talk about repeating blocks, all right? And we will come back with that particular chapter in just a couple minutes.